Yeah, shall we start? Okay, hello everyone. Welcome to the last Blackboard talk in a while. It's my pleasure and honor to give it to you. And it's even my greater honor to give it to you on something that is completely unrelated to astrophysics. We had some talks before about philosophy, philosophy of science, philosophy of Mond. So that all gave me sort of an idea. How about we deviate even further from actual relevant subjects? So this is my talk here. This is as most astrophysics as you will see today, a plan which I didn't even come up with. It's all AI. And before we begin, here is a quick demonstration of what you got yourself into. You see a normal chessboard. It moves forwards, places normally, nothing completely out of ordinary there, except all the things that happened before. You can move back in time with them, creating separate timelines. Right? And then you can move between the timelines back in time. And this all looks very sophisticated. And at some point on Steam, this game had a tag of psychological horror. Yeah, but it's not that horrific. And hopefully you'll see after now why exactly. So before we start talking about how to play the chess in 5 dimensions, or I should say 4, the title is a little bit misleading. We should first try to figure out how to play chess in 2 dimensions. I hope you all have done your homework and know how the pieces moves. Well, now we're gonna extend this to more dimensions. So this is a chessboard. Take a look at it. There is nothing special about it. It's just pieces. Now let's throw all of the pieces out and just focus on one of the pieces, and let's see how this piece moves. This is a queen, for instance. As you can see, the queen can move any number of tiles diagonally, horizontally, or vertically. So instead of thinking about every single square where the queen can move, we instead of it can think about the families of the squares defined by the normal vectors. So for instance, there is a direction here, direction here, direction here, wherever queen can move. Let's define these vectors with a delta R notation. This is the original position of the queen, and this is the final position of the queen. Okay, so then we have a family of 8. Sorry, that thing is cropped off there. A family of 8 unit vectors. But if you consider the fact that there are some symmetries here, obviously, namely a 90-degree rotation, we can actually separate this into a family of 2 unit vectors. The unit vectors which tell you that the queen can move horizontally, right? 1, 0. It also can be negative 1, 0 to move in the opposite direction. And if you perform the permutation of these 2 vector coordinates, it also can move vertically. Same thing with here. This vector corresponds to a diagonal movement, but you also can change the sign of one of them, so it will go down diagonal, or maybe this way or this way. Okay, well, that's great. We can describe the movement of a queen as a set of unit vectors. Now I'm going to overcomplicate things a lot so that it hopefully will be easier later. And I'll introduce this thing called the delta vector notation. Remember those unit vectors that we had as, like, we denoted them as delta R. So now we're going to use this horrendous equation to describe the movement of all the pieces in 2 dimensions. Now, all of this looks pretty complicated, but what does it basically correspond to? You have a vector here that you start with, and this delta here means just this is a delta vector notation and not just an ordinary vector. So this vector, like this notation, corresponds to any vector which is inside of a set of all signed permutations of the components of the vector. And each of those vectors can be multiplied by a number of k, which has to be smaller or equal than the number of m here. Why is this relevant? Well, because if you only consider this vector here, usually if we plug in our unit vectors here, this means that all the permutations would still be unit vectors. So you would not be able to move more than 1 tile. However, if you increase the number of m here, It means these unit vectors can be multiplied and you can move several tiles in a single direction. This still looks pretty abstract. So let's look at some examples. For instance, remember that this thing is horizontal/vertical movements for a queen. And this thing here, this delta vector, even though it's not a vector, it's a set of vectors, corresponds to 4 possible families of vectors. Namely, any vector that goes as many units as you like horizontally, to the right, to the left, up or down. And k here can be any positive number. That's why this infinity sign is here. It means you can go as many tiles as you want. If instead of this infinity you would have had only 1, it means you can only move 1 tile. And if it was 2, you can move only 2 tiles. Here is a second example. Can anyone guess what kind of piece moves like this in these directions? Bishop. Yes. You see that there is a change in 2 coordinates. As many tiles as you want in this direction. This is minus horizontally plus vertically, so this direction. Sorry, I should have swapped this, but it should correspond to this direction. And this one obviously corresponds to the direction to the left and bottom. Now, here's a third example where we finally have something that is not an infinity. When we have here not 1 and 1, but 1 and 2. And this here corresponds to not an infinite family of vectors, because here k can be any positive number, but it corresponds to only 8 vectors. This vector corresponds to 2 vectors. I just didn't have enough space to put them down. So what this means is that this vector means we move 1 tile to the right or to the left and 2 tiles up. Well, this is a knight, right? And as you would expect on an infinite board, completely open, a knight would have 8 moves. 1, 2, 3, 4, 5, 6, 7, 8, right? And here we have exactly 8 vectors. Great. So this is very confusing notation, and you might argue a very confusing way to describe how the pieces move into dimensions, but that will be crucial for us to understand how pieces move in higher dimensions. So these are all the pieces written in this delta vector notation. We already talked about rook, bishop, and king. Knight. The queen here, since remember that this is not, even though I call this a delta vector, it's not a vector, it's a set of vectors. The moves of a queen is a union of all the movements of a rook and all the movements of a bishop. Seems easy enough. The king, if you look at it, is moving exactly the same way that the queen does, but instead of moving as many tiles at once, it only can move once. And the pawn here is weird. I don't like the pawns. Pawns are actually the hardest thing to grasp in this game. So this is not a delta because it's just a single vector. It can only move forward, the pawn. And I put a small asterisk here because, as you know, pawn eats differently. There is also the first move of a pawn and passant. You should Google it, and so many issues. Okay, so great. Any questions about this description of how the pieces move? No problem? Yes, great. Now we have described the movement of pieces in 2 dimensions. Let's now go into 3 dimensions. Let's create a set of boards and sort of smoosh them together into a cube just for visualization purposes. This is not what the game looks like. So remember that we described the move of a rook using this vector. Right? So it moves as many tiles as it wants in a single direction. Well, how do we extend it in 3 dimensions? Well, we have 3 component vectors. Let's just put another 0 here. How does it look like? Well, it looks like this. If you think about this, these 2 moves is our original board, and this is the move in the 3rd direction, in the 3rd dimension, which is orthogonal to the other 2 here. Seems easy enough. Now the bishop is a little bit trickier. For the bishop, you can still think about a single board here, which does look like a move of a bishop, which is diagonal. And if you were to sort of divide, how you call it, a cross section, this cube with differently oriented planes, you would see that this is still a diagonal, and these are still diagonals. But the problem is that if you were to disassemble the cubes, it does not look like a bishop move, which is a little bit confusing to some. Now, you can imagine that we had a bishop and a rook. What is next? Well, next is a knight. A knight gives you a very nice sphere with a Euclidean radius of √5, because 2 squared plus 1 squared, right? And as you can see, it goes twice in a single direction and once in another direction. So this basically describes the moves of the knight in 3 dimensions. Now, there is another piece which we can introduce now in 3 dimensions, which we did not have in 2-dimensional chess. And that is by changing this last 0 here to some number. And they call this piece a unicorn for some reason. And while we had a rook, which had only one of its coordinates changing at a time, bishop which had 2 coordinates changing at a time, so it was moving in a diagonal, this unicorn is moving with its 3 coordinates changing at the same time in a triagonal. You can think about this as going from one corner of a cube to an opposite corner of a cube. And now the things are going to get messy, because we're going to talk about the queen. And the queen is super powerful, and the queen is great. But how do we define a queen exactly? So there are 2 ways to define a queen. One way to define a queen is as a superset of moves of a bishop and a rook. This looks like a rook, right? And the second one would be a piece that moves in a straight line any number of tiles. So yeah, as many as it wants. Now, obviously, in 2 dimensions, these things are identical because you only have 2 directions in which you can move. In 3 dimensions, not really. So this is a weaker version of a queen, which we call a princess. But even though it's weaker, it already looks very messy. You see there is a rook move here, and there are diagonal bishop moves here. How does a queen look like? Well, queen has, in 3 dimensions, it has the moves of a bishop and a rook and that unicorn thing that we talked about, because it also has this triagonal movements. And this is how it looks like if you can understand what's going on. So you see the queen is much more powerful in higher dimensions if we assume the stronger version of a queen. You see there is a rook move here, this would be a bishop move, and this would be this triagonal unicorn move. And for the little, I don't know, brother, husband of a queen, a king, very boring. 1 tile in any direction. Okay, that is a king, and with a king, I believe that's all the pieces, right? Did I describe all the pieces? Except the pawn. But I'm not going to talk about the pawn because I hate it. Okay, so that's how it looked like on a cube. You know, very nice. I spent like a month making that animation. But now let's actually look at how we see this during the game. During the game, we don't see that very beautiful cube animation, which I made, thanks to me. I'm great. But we see a collection of boards. And the movement on this collection of boards here depends. You can, oh, no, wait. I misclicked. Okay, and the movement of this collection boards, you can think about it exactly the same way that that cube was moving. So the rook, you can see here, moves like a regular rook. But here it also goes in the 3rd dimension with only one of its coordinates changing. The bishop is a little bit more confusing because while the regular moves are obviously moves of a bishop, here, if you think about it, it moves like a rook. Like how you would expect the rook to move in 2 dimensions, right? Horizontally and vertically. You do not see this diagonal moves here. But that makes sense because when you're moving in this direction, you are not only moving horizontally or vertically. For a bishop, you're also moving in this 3rd direction. So basically, why does it end up here at the end of this plus shape? +1, +1. Okay, and if we go here, it's going to be +2, +2. So if you want to go end up here, you would have to move like a unicorn, which is a move in 3 directions at the same time. Okay, is that a night time? It is a night time. So for the knight here, +1, +2, it's now a plus, the ends of the plus sign here, but with the size of a 2. And here it's because it already has moved once in the direction, in the third direction. And here it would be the plus sign with the size of 1, because it already has moved twice in this direction. And the princess, even though it looks like a queen, it's not a queen, it's a princess. I just didn't find SVGs of the princess piece, so sorry about that. You can see that it moves exactly like a bishop with this ends of a plus sign, and like a rook, which is this skewer-like motion just through the boards directly where it would be on those other locations. Now look at this, remember this, and let's look at the queen. The only thing that changes between the princess and the queen are these diagonal moves, which are the unicorn moves, which correspond to the moving in 3 directions at once. And the king, I don't even have to explain how the king moves, it's very boring. Yeah, that's it. I think I removed the chessboards. Hopefully people have no issues with how we can extend the pieces moving in 3 dimensions. Now let's go and add another dimension, which is we will have two sets of boards, one orthogonal to another. So other than just the third dimension, which we already looked at, yeah, we'll also have another one. So every piece needs 4 components to describe its coordinates. It's 2 from its position on the chessboard and 2 from which chessboard exactly it is located on. Okay, that's a lot, but it's not that hard. This does not look like a rook, but it is a rook, trust me. As you can see here, moves like a rook here, and in those extra directions, it is moving without changing its position, because just because it is moving through this sets of the boards, it's already considering the change of its position. Now the bishop in 3 dimensions, we already discussed that. That's a plus sign. But what about these diagonal boards? Well, the bishop would not change its coordinate on the board if we move diagonally, because the movement to the diagonal boards is already +1/+1. So that's why you can think about bishop as staying in place as it is moving diagonally in these 2 directions. After the bishop, we have a knight. So after yes, it played. So again, 3rd dimensions we already talked about, but when it comes to an extra, the 4th dimension here, we're going to move twice here and once here. And the coordinate of the knight here would not be changing because we already have moved here. We don't need to change it. Now the princess and the queen. The princess is a superset of moves of a rook and a queen, a rook and a bishop. So you see the 3-dimensional moves of a rook here, 3-dimensional moves of the bishop again. Rook does not have 4-dimensional moves, but the bishop does because as we discussed, +1/+1 here. And the queen has those same exact moves, but it also has some extra moves, which are from the unicorn moves in 3 dimensions. So while the unicorn was looking like a bishop as you are going in the 3rd dimension, in the 4th dimension, it looks like a rook. Right here, these are the unicorn moves because it is +1/+1/+1. But here, the ends of the plus sign would be the unicorn moves, +1/+1/+1. And now we have another set of moves here, which is on a diagonal on this board. And that corresponds to the moves of another piece, which we have not introduced yet, which is a piece which moves in quadrigonal. And you can go as high as you want if you introduce more dimensions. And that would be the moves of another piece, which is a dragon. The way that I remembered it is that if a unicorn and a dragon were to fight, the dragon would obviously win. So the dragon moves better, even though it's a worse piece. Because in order to move the dragon, you need to move it through the time and through multiverse, which I will talk about it in a second. Okay, that is a queen. Great. King, I don't even have to stop at the king, right? Just the queen's moves, but once in every direction. Great. Is that it for the moves? Oh no, look who has appeared. Does anyone know who this is? It's a pawn. Yeah, finally, it is here. So the pawn is very annoying because pawn can only move forward. How do we define a forward? Well, forward we define as away from us. So on the normal board, it all makes sense. But when you are talking about the extra 4 dimensions here, then forward is, well, away from us. So would be in this direction. Also, the first move of the pawn, if you know the pawn has not moved yet, it can move twice. So it can move twice either on the same board or twice in this 4th dimension here. And when it eats, it can either eat diagonally here or diagonally these pieces here. So 1, 1, 1, 1, staying in the same location. So that is a pawn. There is also another version of a pawn which they call a brawn, but I'm not going to talk about it. It's already too complicated. Okay, now the fun part is over. Now I'm going to do a blackboard talk. Okay, so that is all great and all. We can now extend the movement of all chess pieces in 4 dimensions. Where does the time travel come into play? The idea here is pretty simple. Think about the normal chess game as a combination of 2-dimensional chessboard. So for instance, you move a pawn here, you still have your old chessboard, but now the new one, which is a new state of the board, is created. Then your opponent moves the knight, another state of the board is created. And so as you continue doing this, you can think about this as a 3rd dimension. Great, so we have now movement in 3 dimensions. We just have to allow the pieces to move back in time in order for us to have movement in 3 dimensions, which is great. So now I'm going to introduce the rules of time travel. The rules of time travel are very simple, and it boils down to past cannot be changed. You cannot change the past. Never change the past. What happened, happened. So if you have a state of the board that is evolving with time, so for instance, you have a piece here, now you have a piece here, and now like this piece is here or something. If you move this piece backwards in time, using a 3rd dimensional move that we have described, you might be thinking, well, I can just move the piece here, right? Because it moved back in time. But then there comes an issue of causality, which is, if you would have known here that this piece would be here, you would have done a different move. Again, past cannot be changed. So we cannot really do that. We cannot just add a piece here, because then that would alter the state of the board for the rest of the game. So the only way to do the time travel this way would be to pre-calculate all the moves. But that's not a game, that's a movie or a book or something. Now, if you have seen any sci-fi, not recently, for forever, there is another way to go back in time without violating the causality. And that is creating a separate timeline. That is, if you move back in time, you cannot change the past. You can create a timeline where this thing has been changed, and you can have both of the pieces here. That is the multiverse time travel. Huh? Isn't this amazing? We just, from very simple logic and the principle of causality, we have our 2 dimensions of the chessboard and 2 extra dimensions which correspond to the multiverse time travel. Exciting! It's great. Now let's try playing the game. I have a small demonstration for you so you can understand what is going on. So hopefully it will go well. So I move here, I move here. Maybe, I don't know, I'll move here or something. Maybe I'll move here. Doesn't matter how I move. I just want to show you this. Here is a queen. And as you can see, all the past states of the board have already been created. So we can now move the queen back in time based on the rules of 3/4 dimensional movement that we have came up with before. And obviously, if there is a piece in the way of a queen, it cannot move through that piece. That also expands to to third and fourth dimension. So for instance, there is a pawn here, so the queen cannot move through this pawn. That's why this square here is closed. So for instance, we go back to this board, and it will play us a great animation. Give it a little bit of time. Yes, and as you can see, we have created a new timeline. Yay! Now we can also move the queen or any other pieces in this extra timelines. So for instance, here you see I have a knight, the black knight, which can not only go back in time, like the past here does not really exist yet. You know, technically they should have just copied this board here, but let's let them pass here. The knight here also can move in the fourth dimension, right? For instance, here you would have the move of this knight would be one here and twice here. So that's why it would end up here. And again, past cannot be changed. So when the knight moves, it creates a separate timeline. So the fourth-dimensional chess, or I should say five-dimensional chess, but that's a wrong title. So for the five-dimensional chess, it's like you're playing several games of chess at the same time, and they all interact with each other, they can influence each other, and it's a lot to take in. But it's definitely manageable. If you consider that most of the time in this game, you win and you don't understand how you won until you win. I'm not even joking. That is actually how the game works. Okay, so now let's look at the timeline creation rules. So notice that when we moved our white queen back, it created the timeline downwards. And that is what is happening. What is the rule of creating the timelines, the direction of creation of the timelines? The timelines are getting created towards the player. So if I'm white and I played like a piece here, then the timeline is going to be created downwards. And if the black has then played a piece here or something, then the timeline is going to be created upwards. Seems easy enough, I guess. Now, you look at this and you might think that there might be some issues with this. Namely, imagine that you're having a check on this board. A very valid strategy in five-dimensional chess is to escape to the board where you don't have a check. But then you're under a check on that board. What do you do then? Escape to another board back in time where you still did not have check. You see how this can come out of control. So that's why there is a limit on how many active timelines you can have. Namely, you can create as many timelines as you want. For instance, I don't know, let me create here. I know I will create a timeline here, right? See an extra timeline there. And then I'll create another one just because I can. This is getting out of hand. And then, I don't know, black will do something. I don't know what the black will do, honestly. I just want to move faster so I can keep going with my talk. See, this game is very, very fast. It's not a problem. So now let's start creating another timeline here. Let's say I have a queen here, and let's move the queen back in the past here. So another timeline has been created, which is great. I definitely understand what is going on. But notice what is very important here. You see this very small word, the present? Basically, the way that you have to move forwards in five-dimensional chess is you have to advance all the boards in the present. All the boards in the present are the active boards. But here, notice, remember when we first moved our queen back in the beginning of the game before of this monstrosity, the present advanced all the way back and we had to play on this board here. Now, however, as we move the queen back, for some reason, present is not here. How come? Well, the idea is pretty simple, and it comes to that eternal checkmate issue, which I have mentioned before, which is you can create as many timelines as you want, and you can never lose this way. So that's why the way that you calculate the number of active chessboards, which is the chessboards that you can have in the present, is you can have no more than, you can create the number of timelines. Let's say the white creates NW timelines, and it has NW timelines, which are active. They So the number of active timelines has to be less or equal than the number of the active timelines of a black, which means you can create no more than the difference of one of active timelines. And let's look at what we have here. Here we have black, which has created one timeline, and the white currently has created 4 timelines, which is, well, 3 larger than the black. So if white keeps creating more timelines, they would not be active. But if black creates a single timeline, a single new timeline, that the president would shift to that timeline, and we would have to keep playing the game on that timeline. Okay, that is the multiverse time travel issues. Okay, so far, any questions? So, oh, questions, really? Yeah, go ahead.
I don't want to get into this yet, but what about castling?
Yeah, I'll talk about it. Yeah. You had a question?
Maybe I missed this. Is there anything stopping you from bringing your queen back to a board state that the queen was already in?
No.
So you can have multiple, the same piece.
You can have like 4 queens on the same board, and on the same board you can have 3 enemy kings. That's fine. And speaking of multiple kings and dying, how about we talk about how do you actually win the game? So you can imagine that with so much space of maneuvering, it will be pretty hard to checkmate every single king, not queen, king. So in order to win the game, you must checkmate at least 1 king. And checkmating, what does a checkmate mean? It means that there is no moves that your opponent can make which will remove the king out of danger. That is the basic level of it. So that is basically it. You have to checkmate at least 1 king. That's the surface level. There is like a slightly deeper thing, slightly more convoluted definition of checkmate, which we might get into later if we would have time. Now, let's actually talk about fun, because this was not really fun. How about the Jurassic Rook? Anybody interested in the Jurassic Rook? This is like one of the strategies, which is very simple. You play the game normally, and as much as you like, maybe you can stop right about here. And then what you do is you move your piece, which is usually a queen or a rook, and you find a whole set of squares which are open on the way from the rook to the beginning. So what you do is you take this rook and move it all the way back to the starting board. So if you're losing there, that doesn't matter. You're winning here because you have 3 rooks. Okay, the Terminator Gambit, which is a fancy name for an actual strategy, which is called an F7 sacrifice, is a well-known newbie trap in 5-dimensional chess. The basic idea of it, will I be playing it? I think it's too much trouble. So the basic idea there is the king, usually, if it is behind the pawns in 5D chess, is very well protected because other than from the knights,